Coming up. Vector databases is something we use with chatbots and things with AI and LLMs. And it's a way of searching semantically. I got this from a presentation today at FOSS Asia. I thought it was really good, where different parts of speech, you can turn them into different numbers. So here is some emotions, and here's some vegetables, and here's some operating systems. And we'll have different numerical values. So that's a way of searching within a language like English language for the kind of speech. So a lot of times we'll have a vector database to find a user query and find some context from a knowledge base to feed into the LLM's prompt as context. Now, for this database, every page of PDF has a bunch of numbers, like thousands of little numbers, and it works really well. Python it looks at pages of text and converts them to vectors. That's the first one, and then the next one is testing to retrieve them. So the main points of this are, it goes through a folder, and it uses OpenAI. Let me go. I made a more succinct version of this. Let's see. So I put this on. This is on GitHub. I just put it up today. And where is the talk? Okay. We'll go back here. So it reads the text, and then it uses OpenAI, this one, text embedding large, to get the vectors out of the page of text. And then it puts it into each page has got a list of different vectors. So that is done. And then we have another one, which is retrieval. So it's taking the user query and using the same embedding model to try to get something similar to the query. So we have on this page 36, this is a National Electrical Codes, and something like I'm looking for enclosures for electrical equipment. So I'm looking to try to retrieve this page out of my query. And when I do the retrieval test, and I run that, and this is the database I'm going to look at, and here's my query, paste that in.
What does it say?
Equipment. Not a good string here. We'll get off my clipboard. Enclosures for electrical equipment. That's what I'm searching for. So I'm trying to find whichever page is the most relevant for that. Time up. Okay. So here it is, and here's the result. So the very top is the value, and it's sorted by the top 0.5, and here is that page 36, same as this.